inequalities. This is the second half of the first lesson. Broke this lesson into two parts in case you wanted to split up your time. Compound inequalities. We're going to put together what you've learned in Algebra 1, meaning solving basic linear inequalities, and combining it with ands and ors. Most OR inequalities that you encounter will have graphs where the line is shaded to either side. Okay? You are less than 4 or greater than or equal to 10. You can't be both. You're on one side or the other. Most OR inequalities will result in this type of a graph. On the other hand, most AND inequalities you encounter will have graphs where the line is shaded between the points. Think the N is between the A and the D. X is greater than 4 and X is less than or equal to 10. So you're in between. Now, let's see about solving some of these. First off, when graphing, we first need to recall that when graphing a greater than or less than on a number line, you will use an open dot. When graphing a less than or equal to or a greater than or equal to on a number line, you will use a closed dot. Now, I'm going to show you a trick for graphing compound inequalities. These first couple are very, very simple, but sometimes you might want to use this trick when you get a compound inequality that doesn't seem to make sense at first glance. So, this again is a very simple one. T less than 40 and t greater than 32. The solution must satisfy both inequalities in order to be true. So we're going to graph each inequality separately, then our final answer will be the overlap. So if I look at, let's see here, let's first do it in red. If I do t less than 40, I'm going to put an open dot at the 40 and then graph all to the left because that's everything that's less than 40. T greater than 32, well, that's going to be an open dot because I can't equal 32. And then I'm going to graph everything to the right. Now, remember that my answer is the overlap. Okay? Because this is an AND, I must satisfy both equations, or both inequalities. I'm open on the 32, and I'm open on the 40, but everything in between is my answer. So this is how I find my overlap. I graph them separately. This one right here, this is my final answer. I don't want to see this as a final answer. Your final answer has got to be the actual overlap. Now, a solution to a conjunction must solve both inequalities. The solution to a conjunction and inequality is the intersection of the solutions. Next up, we're going to look at a disjunction. A disjunction is an OR inequality. G less than 1 or G greater than 3. In order for the statement to be true, only one or the other inequality must be satisfied. We're going to graph each inequality again separately, and then we're going to graph the combination or the union. So first, I'm going to look at G less than 1. Well, less than 1, open dot on the 1, graph to the left. Then we're going to do G greater than 3. Again, an open dot because I can't equal 3. And graph to the right. Now, because it's an OR, I'm going to do the combination. So I'm going to have everything to the left of 1 and everything to the right of 3. This is the OR combination. Okay? Now, let's take a look at solving a couple of these. You don't always have to do the 3 lines, all right? I simply have them here. so that if you want to do these, you can. I'm going to pull this up here so it's a little bit easier to see all on one screen. So I'm going to take a look at this. When you've got an and inequality set up like this, simply solve each one individually. So over here, I would subtract 3 from both sides, and I have 2x greater than or equal to 4. I would divide both sides by 2, x greater than or equal to 2. Whenever you're doing this, you have to use the word. If you don't have the word, there's a difference between and or, so you've got to have the word in your final answer. I'm going to solve the second one by subtracting 1 from both sides, and I have negative 3x greater than or equal to negative 12. I need to divide both sides by negative 3, so x is less than or equal to 4. Remember that if you multiply or divide both sides by the same negative value, you have to reverse the inequality, which I did there. Now I've got 2 and 4. When you're doing graphs on your number line, you can simply write down the lowest number to the left, the biggest number to the right. Now, if I take and graph greater than or equal to 2, I'm going to have a solid point at 2 and graph to the right. Then less than or equal to 4, I'm going to have a solid point at 4 and graph to the left. Now I want the overlap. The overlap is here to here, and it's a solid point on both ends. Okay, remember that for an and, they both have to be true, and then I can connect them. That's it. There's your answer. Now, if you want to put this answer in interval notation, I would have a solid bracket 2, comma, 4, bracket. Brackets say it's a solid dot. Next problem. Notice that I've got 2a and 2b are the same problem, but one's an and one's an or. So we're going to make this kind of easy. What I'm going to do is I'm going to solve both of them, okay? But really I only have to solve one and just change the word. And I'm going to show you why the word is so critical in your final answer. So let's first start here. This one, I'm going to add 4x to both sides. So I'll have 2x plus 5 less than 3. Now I'm going to subtract 5 from both sides. 2x is less than negative 2. Now I'm going to divide both sides by 2. I'm dividing both sides by positive 2, so there is no reversal. It's a positive number I'm dividing by. X is less than negative 1. I'm going to bring down the word or. Now I'm going to come over here and work on the second inequality. Here I'm going to add 2 to both sides. So 3x is greater than or equal to 6. Divide both sides by the 3. X is greater than or equal to 2. This is an or inequality. I now know that I have negative 1 here, 2 here. X is less than negative 1, open to the left. Greater than or equal to 2, closed to the right. An or means to combine. I'm going to combine these. So my final graph will look like this. And I would have from negative infinity to negative 1, or from 2 to positive infinity. Now what happens, however, if I do an and? Well, I don't need to rework the problems because the numbers are going to come out the same. It will be x less than negative 1 and x greater than or equal to 2. So I'm going to come over here, and I've got -1, and I've got 2. Again, open to the left, closed to the right. Because it's an and, I want the overlap. There's no overlap. There is no overlap. So if this is an and, there is no solution. There's no value of x such that both inequalities will be satisfied. Notice, if you leave out the word and or, there's a huge difference. If it's or, I have an infinite number of possible solutions. If it's an and, I got nothing. Make sure you keep the word in your final answer. Let's take a look at another one. Same kind of thing. We're going to just looking at why it is so important to actually put the words into your answer. I'm just moving these up so they fit on the screen. If we take this first one up here, I'm going to subtract 7 from both sides, so x is greater than or equal to -5. And I'm going to divide both sides by 2, x greater than or equal to 2. This is going to tell me that I want some overlap. Well, if I have -5 here and I have 2 here, -5, if I first graph this one, I have a solid point and I graph to the right. X greater than or equal to 2, I have a solid point at 2 and I graph to the right. If I want the overlap, I'm only overlapping here, so I have a solid point at 2 and graph to the right. In interval notation, that would be 2 to positive infinity. Okay? The overlap, it only overlaps everything greater than or equal to 2. So I can actually also just circle this. In this case, I don't actually need an and. Okay? Now, if I put it in as an or, I would have x greater than or equal to -5 or x greater than or equal to 2. Let's put the -5 here and the 2 here. Again, from -5 greater, from 2 and greater. Now I'm going to combine them. Well, that's from here to infinity. So I'm going to have from -5 to positive infinity. That means I go -5 to positive infinity, and this becomes my answer if it's an or. Notice there is a difference. It makes a difference. The word and or matter. Okay, in summary, you have seen there are many ways of representing the same interval of values. These ways may include word descriptions or mathematical symbols. The following statements and symbols all represent the same intervals. All numbers between +1 and +5, including the 1 and 5. 1 less than or equal to x, less than or equal to 5. X is less than or equal to 5 and greater than or equal to 1. Here's another way of showing it. The first way is just pure inequalities. The second way is adding on some fancy stuff, the set builder notation. And then finally, x is between 1 and 5 inclusive, bracket 1, comma 5, bracket. Shorthand, interval notation. When you solve each portion of an or compound inequality, you solve each section separately. And inequalities can be solved separately when written using the word and, or together without the and when written as a sandwich. Okay? Notice x greater than 2 and x less than or equal to 4 is the same thing as 2 less than x less than or equal to 4. Answers must be written as conjunctions or include the word or and to be correct. Interval notation is an alternative form of writing the solution to an inequality. Okay? That's it. Good job.